So in this demo, the front end is developed using Angular. I have already put in the query below. What is the medication utilization threshold? The idea here is that when the user clicks the submit button, then this query goes to the backend where the vector representation of this query is computed. It is then compared with the existing vectors which we have already created based on this file. This is a PDF file and it has been chunked into multiple text inputs for which the embeddings are created and stored. Now when the user hits the submit button, the query goes to the backend, and once the embeddings are computed and compared against the stored vectors, we create a prompt, and that prompt is sent to ChatGPT, which then returns back the response. The ChatGPT response is now based not only on its own memory, but the context that we provided based on the PDF file. So it would be like more accurate. Now let's look into the backend design component architecture. For the front end, we are using Angular. The backend is developed using Python. The vector embeddings are stored inside the pinecone database, while Atlas is used for visualization of these vector embeddings. The OpenAI ADA model is used for getting the embeddings based on the text chunks, and the GPT 3.5 turbo model is used for getting the prompt and response. It is a two-phase process. The first is the embedding phase. In the first phase, we have these PDF documents which are sent as input to the backend PDF parser, which is implemented using Python. The parser breaks this PDF into chunks, and these chunks are then passed into the OpenAI model. For every chunk, the vector embeddings are created and then stored inside the pinecone database. These vector embeddings are 1536 in dimensions, essentially numbers. Embeddings which are similar to one another are grouped, and they provide a correlation matrix, which we can see at the bottom of this page, where the green dots include all the embeddings or vectors which are similar to one another. This is another visualization of the same. The green dots are the ones which are similar to one another. If we click on the dot, it also gives us the ID as well as the metadata. In this case, this chunk is related to CCM, complex care management, while this chunk is also related to the same thing. So those are grouped together. The Pinecone database has an index called as medical vector. This index has 173 vectors which are already stored inside it. This index is then used for generating these embeddings. Now if we go to the next phase, this is the query phase. In the query phase, the user inputs a query that is sent to our orchestrator. The orchestrator then takes that query and hits the OpenAI ADA model to get the vector embeddings. These vector embeddings are then compared against the already generated and stored embeddings on Python in Pinecone, which returns the top match based on the score. Higher the score, better the match. This embedding that is returned, that's put as the context as part of the prompt, and the query from the user is copied as it is. And this dynamic prompt is then sent to GPT 3.5 Turbo, which returns a response that is shown back to the user. This response is now taking into account the context which we provided through the pinecone vector embedding. Typical use cases for this include turning any document into a semantic searchable repository. The vector embeddings allow us to extend the memory of LLMs by providing additional context. We don't have to rely on its own training, but can provide training based on our vectors. Also, we can create recommendation engines like book recommendation, product recommendations. Hybrid search can be implemented. One part would be the keyword search traditional plus the semantic search powered by vector embeddings. Some use cases which we can implement include customer support, customer self-help use cases, image match, audio match, and so on and so forth.